Okay, so last time we have defined the fundamental group. Well, we have a based topological space, and then we have the so-called loop space. So this is just the set of loops starting and ending at the point x0, and then we defined an equivalence relation on this homotopy relation. Alpha is homotopic to beta. If there is a homotopy, meaning that a continuous map from I cross I into X satisfying f of S0 is alpha S, f of S1 is beta S, and f of 0t and f of 1t is just x0. We picturally, write the following. So this is f. Let's say this is the s-axis. This is the t-axis. And so here f is just alpha. Here it is beta. And at the other two edges, it is constant equal to x0. Now, this relation is an equivalence relation. And the set of equivalence classes is called the fundamental group of the base space x0. We defined, of course, one has to define group operations. Group operation is defined this way. If we have two homotopy classes, then this is just defined as the homotopy class of this product. So what is this? This is another path, and it is defined as follows. In half the time, you go via alpha, and in the remaining half time, you go via beta, sorry. Okay. This is the operation. We showed last time that this is a well-defined operation. In other words, it is independent of the choice of the representatives of the equivalence classes. And then to go further, we need identity element. Okay. So group axioms. What are they? We need identity element. I will denote this function by E, and its equivalence class I will also denote it by mostly E. So this is just the constant function. Okay, constant function. We claim that this is the identity element. So what we claim, E times alpha is the same as alpha, and alpha times E is again alpha for all alpha in pi1 x x0. so that this is identity element. The proof is easy. Okay, so proof. Let me do the proof on the other board. Kahvemi içeyim. Ha yok, şurada yapabiliriz ya. Niye oraya gidiyor? Pardon. Şöyle yapalım. So proof. Okay, now alpha dot E is what? So the element here, well, by definition, half the time we go via E in the first half, and in the second half we go via alpha, right? Ha evet, evet, öyleydi. Two S, evet. Şimdi bu şuna denk geliyor. Picture olarak yazarsak şöyle. Şimdi zamanın yarısında değil mi? Alfa gidiyoruz. Geri kalanında E ile gidiyoruz. Ve biz ne yapmak istiyoruz? Bunun alfa ile aynı şey olduğunu, değil mi? Yani ona homotopik olduğunu. So we want this. So I need to write a homotopy which joins this path to this path. Okay? Of course, E, the map E is just the constant map, right? X0. So I can just write it this way. And my homotopy, of course, should be also constant at these two edges. Then this is what you do. You draw this line segment. Okay. So this is basically analytic geometry. And then you write the following function. So it was alpha here, right, with speed 2 times the usual speed. So what you do, you just write alpha here with slower and slower speed, so that at the end of the homotopy, it has unit speed. And here on this side, it will be just the constant function x0. This way, you will homotop alpha to, this composition to alpha. So here you are going 2 times faster, and then you stop here. What you do, gradually you just slow down, okay? Yani bir loop'u 2 katı hızlı gidip sonra başlangıç noktasına gelip yarım saat yatıyorsunuz. Onun yerine diyorsunuz ki işte 35 dakikada gideyim, 25 dakika yatayım. Ondan sonra işte 45 dakikada gideyim, 15 dakika yatayım. En sonunda da yavaş yavaş gidip 1 saatte gidiyorsunuz. Tamam mı? Yaptığınız işlem o. So each time you just slow down, okay? And finally your speed becomes unit speed. And how you write this? Well, this is, so you just let F as T. So this is my T axis from 0 to 1. And this is my S axis from 0 to 1. So I just write this function. Alpha of 2s divided by 1 plus t as between these two. Here, this is the line parameterized as follows. This is just 1 plus t divided by 2t as t ranges from 0 to 1. So at time 0, you are at this point because it is 1 over 2 comma 0. At time 1, you are 1 plus 1, 2 divided by 2, 1, 1, 1. So you are at this point. So this is just the parameterization of this point. And what you do at this point, t, you go here along alpha, and s goes from 0 up to this point, which is 1 plus t over 2. And in the remaining time, once you are here, you are at the point x0. So because when s is this, this becomes just 1, right? When s is 1 plus t over 2, this thing becomes just 1 because it is just inverse of that. And here you just write x0 as s 1 plus t over 2 and 1. Tamam mı? Yani şu resimde gördüğümüz şey yapıyoruz. So this is the homotopy. Joining E composition, no, alpha composition E to alpha. We can write down a similar map or homotopy for the other composition. So similarly, for E composition alpha, we can write the homotopy. Orada da işte ne yapacağız? Şunu yapacağız. F of yani bu sefer şöyle, değil mi? So here, this time here it will be E, and here it will be alpha. This time we will do it this way. Burada x0 olacak. Şurada from t equals 1 over 2 to 1, you were going along alpha. Each time you just increase the interval here. Finally, it becomes the whole interval. And this function, f, is just what? fst. So it will be what? Bunu yazmamışım. Aslında bunu evet belki egzersiz bırakabilirdim size. Şunu exercise. Aynı şeyi yapacaksınız. Yani şunu bir, you have to parameterize this line segment, and then you will go along this path via E, which is constant function, and then on this line segment, you will go along alpha with appropriate speed, of course. Değil mi? Hızınızı değiştiriyorsunuz. So here, you know, as t increases, your speed is changing. Değil mi? S'in katsayısı sizin bir yerde speed'inizi gösteriyor. T eşittir 0 iken hızınız 2 birim. T eşittir 1 iken hızınız 1 birim. Tamam mı? Now, the second part is the inverse element. Inverse element. So for any alpha, you need to So given alpha from 0 to x, you need to write inverse element. Just define it this way. What should be the inverse element? Well, you should just trace alpha backwards, right? So it should be this thing. Alpha bar s should be just alpha of 1 minus s. So that as s equals 1, you are at the point alpha 1. And if s is 1, no, sorry, if s is 0, you are at alpha 1. If s is 1, then you are at alpha 0. So you just go along the same path, but in the opposite direction. Tamam mı? Tabii ki neyi göstermemiz lazım? This is clearly continuous, but we must show that this is really the inverse element in the group with respect to the group operation. So we have to prove the following. Alpha composition, this should be the identity element, and also the same the other composition should be the identity element. Okay, let's see how we can do this. So şöyle yapalım. To see this, consider the homotopy. İlk önce resmini çizelim yine. Ondan sonra fonksiyonu yazmak hani teknik bir şey. Şöyle olacak. Şimdi şurası diyelim ki alfa, şurası alfa bar. So this is the composition. First you go along alpha and then alpha bar. This is 1 over 2. What you do is the following. Burak Hoca'nın sesi de bayağı gür değil mi? So what you do is the following. Here in halftime you go alpha, and in the other halftime you go alpha backwards. What you do, here you will go alpha, but you will not reach the point you start with. Okay, you stop before you reach the base point, and then you wait there, whatever that point, and then you just go back. Okay, each time you do this, you go a little. So first you go all the way along alpha, and then you come back. But then you do the following. You go a little bit, you stop here, wait for a while, and then you just come back. And then you go again a little bit, but this time you go shorter. You wait for a while, and then you come back. And when you reach here, you don't move at all. Okay? You just stay at this point. Therefore, this composition is homotopic to x0. So your function will be x0 here, constant function. It will be here alpha, but not the whole alpha. Okay? Nereye kadar? İşte zamanınız ne kadarsa o kadar. Burada da şu geldiğiniz şeyi tekrar geri gideceksiniz. Tamam mı? Nasıl sürekli gidip gelsek? Ama yani sonuçta ben sabit pete homotop etmek istiyorum ya. Yani bu homotopinin bu ucu sabit olmalı. Sürekli gidip gelirsen nasıl o homotopik olacak? Yani bu gidip gelme fonksiyonunu hiç gitmemeye homotopik yapmak istiyorum. O yüzden de ne yapıyorum? İlk önce bütün yolu gidiyorum. Sonra diyorum ki hepsini gitmeyeyim. Biraz yarım gideyim. Bekliyorsun, sonra geliyorsun. O şekilde. En sonunda da hiç gitmiyorsun. Senin dediğin fonksiyon continuous olmaz. Yani her seferinde gidiyorsun, geliyorsun, gidiyorsun, geliyorsun. Sonra hiç gitmiyorsun. So here is the map. Okay. Let me just write down what are these points. So they will be important. Okay. So this point is 1 minus t over 2 comma t, and this point is 1 plus t over 2 comma t, okay? And here is the homotopy FST. Yani tamamen analitik geometri. 2 kat hızlı gidiyorsunuz ama yani zamanın tamamını kullanmıyorsunuz. 1 eksi t bölü 2'ye kadar. So here you are going 2 times faster from t equals 0 to 1 over 2. Here you go 2 times faster from s from 0 not up to 1 over 2 but up to this point. So you don't go the whole way. You just stop in the middle and just wait there. And then, of course, when you reach this point, you are at the point alpha of 2 times this, which is alpha 1 minus t. So you stay there. How long? From this time to this time. And then you just go back. 2 over 2 minus 2t. 1 plus t over 2 s1. Buraya 2 yazıyoruz. 2 eksi 2s. İsterseniz kontrol edelim. Gerçekten bu şey mi? What is, for example, f s0 when t equals 0? When t equals 0, okay, let me write it this way. When t equals 0, this is just 1 over 2. So 0 s 1 over 2. And you go like this. When t equals 0, this is just s. So this is 1 over 2. This is 1 over 2. So this is just 1 over 2. And what is this? Alpha 1. So you are at the point x0. And then when t equals 0, when t equals 0, this is just 1 over 2. 1. And you have 2 minus 2s. So when s is 1 over 2, it is alpha of 1. When s is 1, it is alpha of 0. So you just go alpha backwards, okay? It is not alpha, but alpha bar. So this thing is actually alpha bar. So this is just maybe, okay. Alpha 2 minus 2s is just, nasıl yazarım bunu? Alpha 1 minus 2s minus 1, right? So this is just alpha bar of 2s minus 1, right? Alpha bar s is alpha of 1 minus s. So alpha of 2 minus 2s is just alpha 1 minus 2s minus 1, and that is just alpha of 2s minus 1. So this thing here is just alpha bar of 2s minus 1. Yani alfa ile alfa barın kompozisyonu olacak. This is continuous function because at the end points, so the end point here just this thing. At the end point, this function and this function are the same. And again, at this end point, this function and this function are the same. So if it's continuous, and if, of course, so what is this? This is nothing but, this thing is just, bu nedir? Alpha bar, right? This thing is just alpha bar. What about this gadget? When t equals 1, this is just 0. So s is just between 0 and 0. So s is just 0. Therefore, this is alpha 0, which is x0. When when t equals 1, this is 0 and this is 1. And you have alpha 1 minus t. Okay, t is just 0. No, t is 1, sorry. But, yeah, okay. T is 1, but 1 minus t is 0. And then, so this is again x0. And then alpha of, when t is 0, this is 1 over, no, t is 1, sorry, t is 1. So it is just 1, s and 1. So s is just 1. So when s is 1, this is again alpha 0. So what you see, your function is just equal to x0, x0, x0. So this is just the constant function x0, so it is just e. Therefore, this is a homotopy from this path to the constant path. Hence, alpha bar is homotopic to e. Okay. Similarly, you can write alpha bar, alpha is homotopic to e. Therefore, alpha bar is really a loop that represents the inverse element in the fundamental group. Okay. Bunları böyle hani öğrenmenin en iyi yolu bir kere oturup kendinizin aslında yazması. Hani dediğim gibi analitik geometriden öte bir şey yok burada ama hani bir kere oturup yapmak lazım o işlemleri. Okay. The third group axiom is associativity. So let alpha, beta, gamma be 3 elements in this object. So we claim that alpha, beta, gamma is homotopic to alpha dot beta dot gamma. Okay. And proof is again just linear algebra. I'm sorry, analytic geometry. First, I have to draw a picture. So proof of the claim. Let's draw the following picture. Okay, so what is this? Well, in half time, I go along alpha. In the remaining half time, I go along beta composition gamma. But this is another, composition. So it will be like this. 3/4. It will be beta here and gamma here. What about this one? Well, here in half time, you go along alpha times beta. So it should be like this. Alpha here, beta here. And in the remaining half time, you go along gamma. So what you do, the time you use for alpha will decrease from half time to quarter time, right? This is 1/4. This is 1/2. The time for you use for beta doesn't change, but the interval is shifted, and the amount of time you use for gamma will increase from quarter time to half time. So what you do, you draw this parallel lines, okay? Parallel lines, and then okay, at any t, okay? So this will be your alpha, this will be your beta, and this will be your gamma, okay? So you have to know what these points are and so on. Okay. Let me tell you. First, okay, to make notation simpler, first I define this function LTS. So what is this? Let me write down and then I will explain. 4s divided by 2 minus t, for s between 0 and 2 minus t divided by 4. So this 2 minus t divided by 4 is this point. Okay, 2 minus t divided by 4. And then your function is just 4s plus t minus 1 for s between 2 minus t divided by 4 and 3 minus t divided by 4. And then it is 4s plus 3t minus 1 divided by 1 plus t, 3 minus t over 4 between this point and 1. So this point is just 3 minus t divided by 4. Okay. Fonksiyon ne yapıyordu? Unuttum ama. Yani sonuçta şunu sanırım şey yapıyordu bu evet. Bu fonksiyonun yaptığı şey şu. It maps this interval to the interval 0, 1. So yani şurada şimdi alfa kadar gidiyorsunuz ya. Burada da alfaya gideceksiniz. Bütün alfaya gideceksiniz. Dolayısıyla hızınız sürekli değişmeli. İşte onu veren ifade bu. Bu fonksiyon 0, 2 eksi t bölü 4'ü 0, 1'e map ediyor. This function maps this interval again to 0, 1 mı yoksa bakayım. Yok. 1, 2'ye map ediyor. This function maps this interval to the interval 1 to 2. Yok. 2 to 3. Evet. İsterseniz şöyle yapayım hatta. Bu fonksiyonun grafiği şöyle bir şey. İki eksi t bölü 4 3 eksi t bölü 4 şurada da 1 var. Bu LTS fonksiyonu şöyle bir şey. Şöyle yani kırık bir çizgi olması lazım. Atıyorum. Okay, şöyle bir şey. Yani şurası 1, şurası 2, şurası da 3 olmalı. Okay. LTS. Sonra ne yapacağız? F'i şöyle kuracağım. FST homotopimiz alpha of LTS as between 0 and 2 minus t over 4. Yani şu aralıkta alfaya gideceğim. Bu fonksiyon işte bu aralığı sıfırdan 2 eksi t bölü 4'e kadar olan aralığı 0, 1'e map ediyor. Onu direkt alfanın içine koyuyorum. Beta'nın içine koyacağım şey bu olacak. LST. Ama bu fonksiyonun grafiği dikkat ederseniz bu aralığı 1-2'ye gönderiyor. But inside beta I should put something between 0 and 1. Therefore I subtract 1 here. So 2 minus t divided by 4 pardon 3 minus t divided by 4. 1 çıkartıyorum ki görüntü kümesi 1'den 2'yeydi. 1 çıkartınca 0'dan 1'e oluyor. Beta'nın içine onu koyuyorum. And here we put LTS but I subtract 2 because inside of gamma I should put a number between 0 and 1 and the image of this on this interval it is between 2 and 3, so you subtract 2. Okay. Here 3 minus t over 4 and 1. Yani resim size ne yapmanız gerektiğini söylüyor, değil mi? Şu resim. So this picture here gives you how should you write down the homotopy. Okay? Tabii ki tek homotopi bu değil. Yani başka homotopilerde yazabilirsiniz. Bu bir yerde hani en straightforward olanı. Okay, of course one should check that. So let me. So one must check that f s0 when t equals 0, this function is just alpha times beta times gamma, and fs1 is just alpha times beta times gamma. İsterseniz bir tanesini yapalım. Yani L t'nin 0 olduğu duruma bakalım. So L 0t 0 s is what? T yerine 0 yazıyorum. When t is 0, this is just 4. So when t is 0, this is 4s divided by 2. So it is just 2s, and s is between 0 and 1 over 2. And then when t is 0, this is just 4s minus 1. And t is 0, so this is 1 over 2 and 3 over 4. And when t is again 0, this is 4s minus 1 divided by 1. 4s minus 1. Again, this is so this time 3 over 4 in 1. Peki şey nedir? F fonksiyonu f0 fs0, so alpha of L, so alpha 2s, sonra beta L minus 1. So L is just this gadget. I subtract 1 from this, so it is 4s minus 2. Ve burada da gamma 4s minus 1 ama 2 çıkartıyoruz. 4s minus 3. S de 3 bölü 4 ile 1 arasında. Şimdi bakalım S sıfırdan 1 bölü 2'ye kadar as S goes from 0 to 1 over 2, alpha goes from 0 up to 1. As S goes from 1 over 2 to 3 over 4, this goes 1 bölü 2 koydun. When you plug 1 over 2, you get 0. When you plug 3 over 4, 4 ile çarptınız. 3, 2 çıkardınız 1. So it goes from 0 to 1 again. And this one, when you plug this, 4 ile çarptınız. 3 çıkardınız. So it is 0. And when S is 1, it is 1. So it goes from again 0 to 1. And so in half time, you go alpha. And in the other half time, you go beta and gamma. So beta and gamma. Tamam mı? Peki. So fundamental group is really a group. We know that. Then the next thing you ask, okay, how can we compute this group, right? Okay. Some examples. Okay, now for any convex subset x of Rn and any point x0 in X, the fundamental group pi1 x0 is just the trivial group. So it has only the identity element, the trivial group. So a convex subset in that sense is not interesting, right? The fundamental group is just trivial. And why is that? Proof. Now X is convex. Since X is convex, for any given points, P and Q in X, X contains the line segment. The line segment parameterized by T goes to T times, no, 1 minus T times P plus T times Q lies in X. Here T is between 0 and 1. So what is this? This is just, so it's a set like this, okay? Bu olmadı. Değil mi? Konvekse şöyle olabilir. Daha şu da olmaz. Şöyle. Convex. Whenever you choose 2 points, the line segment joining these 2 points should lie inside X. Okay, convex sets are like this. Peki, o şey niye o zaman fundamental group 0 olacak? Şu yüzden take any alpha in pi1 x x0. So let's choose a base point x0, and I choose any path starting and ending at 0. Define the homotopy. Homotopy. Which homotopy? Well, whenever you have a path starting and ending at this point, okay, I can just join the point alpha of S to this point, right? And I know that since the set is convex, this line segment lies inside X. Therefore, this is a well-defined map. Alpha, sorry, f of st is just 1 minus t alpha of s t x0. Okay, this is just the line segment joining alpha s to x0. Its image is inside x because I know that this line segment is in x. Okay, and this is clearly a continuous function. Why is that? Because alpha is continuous. You multiply it by this and so on. So this is a all these things are in convex set. Maybe I should say in some Rn. Okay. Yani convex set de nerede, değil mi? Okay. Suppose it's in Rn. So this is a continuous function. I have to check that this is a homotopy from alpha to constant path. Well, when t equals 0, when t is 0, this is just alpha s, right? And when t is 1, this time this is 0. So this is just constant function for all s. Therefore, alpha is just homotopic to the constant path, okay? This means what? The homotopy class of alpha is the same as the homotopy class of the constant path. So what we have seen is that I chose any element in this group and I saw that that element is the identity element. Therefore, in this group, there is nothing but the identity element. Tamam mı? No, that's not true. For example, circle is arcwise connected, but fundamental group is not trivial. So that proof, this proof breaks down there. For the circle, it doesn't work. Why it doesn't work? So suppose, okay, you have this, and consider this path, okay? And you think that I can just slowly take this path and homotop to the constant path, right? But the thing is, you know, okay, every point you use this right path to trace this point back here. Instead of line segment, you may use this point, I mean this arc, but when you come here, so up to here it's okay, you can do this, but when you come here, that process is not continuous, okay? You have to break this circle. And that is actually our next theorem. Let S1 be the unit circle in R2, then I1, S1, X0. X0 is just any point, or well, we will see later that it doesn't matter which point you choose, but for time being, let's choose this point. Is isomorphic to the infinite cyclic group of integers. Okay. Well, there are several proofs of this. None of them is is simple. Unfortunately, there is no simple proof of this. But actually, this is the only non-trivial example you show that the fundamental, you compute the fundamental group directly. Okay. For all other spaces, maybe for spheres, yeah, we will show that we will compute fundamental group directly, but for all other spaces, we will use some other tools, okay, to compute them. We will not compute them directly. We will just use the fundamental group of spheres. And for the spheres, this is Z, and for all other spheres, it is trivial. For the 2-sphere, 3-sphere, and so on, fundamental group is trivial. So this is the only non-trivial fundamental group. So circle is the only sphere that has a non-trivial fundamental group. And then we will just use this to compute fundamental groups of other spaces using some theorems. Sorry, let me stop the recording. Ya da söyle, what was the question? No. Any group can be a fundamental group. Almost any group. I shouldn't say any group because I don't know all the groups, but the groups I know, at least the discrete groups, but including R, they are all fundamental groups of some spaces, all finite groups. You can make Q fundamental group of some space, even R. We don't have a surface, but we have a topological space. No, we have surface. I am sorry. Okay. The projective plane RP2. This has fundamental group Z2. And it is actually the only surface which has finite non-trivial fundamental group. RP2, yeah, this is the real projective plane. It is plane. It is just, okay, I mentioned this a couple weeks ago. It is just, by definition, the sphere divided by the quotient space divided by the action where you identify any point with its antipodal point. Okay. On the 2-sphere, just identify antipodal points. You get another surface that's a real projective plane. So this is the projective plane where you make projective geometry. Okay. Yeah, okay. How can we visualize? Okay. Şu kaydı durdurayım da. Ara verelim bu arada isterseniz. Kusura bakmayın.